This is Algebra 2, Lesson 25, and we're going to be talking about factoring. So when we're factoring, we're doing kind of like undoing what we do when we rainbow something. So 25.1 asks us for the factors of 4ax squared plus 4xy. Okay, and we're supposed to pull factors out of that. All right, so if we look at this, both of these terms have a 4, so we're just going to write our 4. They do not both have an a, so we have to leave the a. They do both have at least one x, so we're going to say 4x. Then we're just going to write times, and then we're going to see what's left. Another way to do this, I'm going to work this one out and do this differently for this first one. So let me write it up here. 4ax squared plus 4xy. Okay, so I'm going to write out all the things that are in here. So I have 4, and then I have 1a, and then I have 2 x's. In this one, I have a 4, and I have an x, and I have a y. Now, both of these have a 4. Both of these have at least one x. Okay, now what's left? A and x in this one. And this one, the only thing that's left is a y. Okay, so basically we did the opposite of rainbowing. If we rainbowed this and we said 4x plus times ax, we would get 4ax squared. And then if we rainbowed it right here, we would get 4xy. So we're just undoing the rainbow, the distributive property. We're picking out all the factors for each one. All right, let's try another one. 25.2 is 4x squared p squared k minus 6k squared p to the 4th x. Okay, so on this one, if we picked out the factors of 4, that would be 2 times 2. Makes 4. 2 times 2, and we've got 2 x's, 2 p's, and 1 k. So that's all the stuff in there, just written out. This one would be 2 times 3, 2 k's, 4 p's, and an x. Okay, now we have to find the common factors. So we've got 2, both of them have a 2. 1x, we've got a 2, we've got an x, 2 p's, and they've both got a k. Okay, now what's left on this side? Just the 2 and the x. And then on this side, we've got a 3, 1k, and 2 p's. You don't have to write them all out like this every time. You can just do it by looking at it. But if you're getting confused, writing them out like that can be really helpful. All right, let's try it just by looking at it. So I could say that what goes into 4 and 6, well, 2 goes into both of those. X's, they all have at least one x. The lowest number of p's there is p squared and 1k. And then I'm going to look at this equation. I'm going to say, all right, 2 goes into 4 2 times. X goes into x squared once. We already took 2 of these p's. And there's already that, so no p's and no k's. And then 2 goes into 6 3 times. And we used 1 of the k's, so we've got a k left. We used 2 of the p's, so we've got 2 p's left. And we used up all the x's. So that's exactly the same thing that we just got the other way. But if you're getting confused, go ahead and write out all the factors and then just circle the ones that are common. All right, here's another one. 25.3, 4x squared y minus 2xy plus 10xy squared. Okay, on this one I'm going to look at all of my numbers first. 2 will go into all those. X's, everybody has at least one X. Y's, everybody's got at least one Y. Alright, now 2 went into 2. Let's see, if I've factored out 2 out of that 4, I'm going to have 2 left. I'll have one X left, and I won't have any Y's. Used to one of the Y's. Alright, on this one, I don't have anything but a 1, an X, and a Y. It's just going to be 1. That whole thing goes one time. 2xy goes into 2xy one time, negative 1. Alright, and then 2 goes in 10 5 times. We used the X, we used one of the Y's, so we got one Y left. So that's the answer to that one. And if you multiplied this back out, you said 2 times 2 is 4, X times X is X squared, and then a Y, and then we said 2 times negative 1 is negative 2, and then the X and a Y, and then if we said 2X times XY times 5Y, you would get that one. Alright, so that's it for those examples. These are really, really easy, guys. Just don't get confused. Sometimes they're extra long, and it helps to write everything out. Alright, so when we cancel something, let's say that we have 4x over 4. We can cancel those 4's. But if we have 4 plus x over 4, we cannot cancel those 4's. The reason why is we can only cancel things that are being multiplied, only factors that are being multiplied. In this one, we had 4 times x. We could cancel that because this is 4 times x divided by 4. In this one, we have 4 plus x divided by 4, and we cannot cancel that because it's not 4 times x, it's 4 plus x. Alright, so we're going to learn how to do some of these. So if we had 4 times x plus 2 over 4, we can cancel right here because that means 4 times x plus 2. Times and divided by. As long as this is in parentheses, then we can. And that's just going to equal x plus 2. Okay? If we had x plus 4 divided by 4, we can't cancel anything. Okay? Because there is no factors on the top. We can only cancel factors. Alright, 4x plus 4 divided by 4. Now, we cannot cancel any of these right now. We can't cancel this 4x because that's not just 4x, that's 4x plus 4. But we can factor that. So, on the top, we have 4x plus 4. Both of these have a 4 in them. So, this can equal 4 times x plus 1. Okay? They both have a 4, so we write our 4. And then what's left out of this term? Just x. 4 goes into 4 how many times? Just one time. Okay? So that whole thing on top equals 4 times x plus 1. If we put that over our 4, then we can cancel, and this whole thing cancels down to x plus 1. Alright, super important. Alright, so 25.4 says 6x to the third plus x squared over x squared. Okay, so I can take x squared out of both of these. So I'm going to say x squared times this first factor, the 6 is left, and one of the x's is left. This one will just be a 1. How many times does x squared go into x? One time. And all that is over x squared. Now these can cancel, and I'm just left with 6x plus 1, which is the answer to that one. Alright, that's all of that. And then there is also another little part about parallel lines. So this line right here and this line right here are parallel. When we see parallel lines, we could go ahead and mentally, in our minds, extend those lines out. We end up with crossing lines. And this looks a lot more like something that we've done before. Remember that when we have parallel lines and lines crossing, we end up with pairs of angles. So here and here are all going to be the same, which means that if we follow this line up, let's see, this one's, yeah, that one's parallel. That means that here is going to be the same as there. Okay, so those are going to be because this line is parallel to that line. So here and here. All right. We can also find this line is parallel to that line compared to this one. So here would be the same as here. Okay. And then the two lines that are crossing, we would have this one and this one. That means that this side is that side. Okay, those are going to be corresponding to each other. And this one's opposite side would be here, and its opposite side would be there. So those are going to correspond to each other. Okay, and then this one's opposite side is here, and this one's opposite side is here, so those are going to correspond to each other. Okay? Alright, so that's super basic. You guys probably already knew that. Alright, go ahead and do the practice problems, and then I will come back and work them for you. Alright, we're going to start with practice A. It's a big long one. It's got 8m squared x y to the 5th plus 6y x squared m to the 3rd minus 2xy m squared. Phew, that's a long one. Alright, so I'm going to figure out what factors I have here. And 2 will go into all those. So I'm going to start with a 2. And then my m's, I got m squared, m to the 3rd, another m squared. They all have at least 2 m's, so I can do an m squared. My x's 1x, 2x's 1x. So I'm just going to do 1x. And then my y's, that's a y to the 5, y to the 1, y to the 1. So I'm going to go with y to the 1. Alright, now I got to figure out what I factored out of this first one. I factored out a 2, so that would leave me with a 4. 2 times 4 is 8. I factored out that m squared, so they're all gone. All the x's are gone. One of the y's, so that would leave y to the 4th. So that's my first term. Now my second one, 2 goes into 6 3 times. M's. I took out 2 of the m's right here. This one has 3, so I'll have 1 m left over. Alright, my x's, I factored out one of the x's. I'll have 1 left over. And I factored out 1 y. That's all that I got there. Alright, then my 2, I factored that out. So we're just going to put our minus sign. Our m squared, factored that out. Our x, we factored that out. And our y, so it's just minus 1 on that one. So 4y to the 4th plus 3mx minus 1. So that's the answer to that one. Okay, let's try B. B is 4m to the 5th plus m squared over m squared. Now, I can't cancel these yet, but I notice that I can pull m squared out of both of those factors. So I can say this is equal to m squared times, I didn't do anything with the 4, so I'm going to leave the 4. I took 2 of those m's. I'm going to have 3 m's left. I took all this, so it'll just be a 1. These are going to cancel, and your answer should be 4m to the 3rd plus 1. That's the answer to that one. It's B. Alright, C. Practice C looks like this. And I could go ahead and pull some of these. So I could say my little triangle looks like that. And it's got a 2 and a 3 and a 4. And then my big triangle looks like that. And it's got 2 and 3 would be 5. And then y. And then 3 plus x. Now on this one, it didn't tell you that. It just only told you that one was equal. So that means this and this. it didn't tell you that these were equal, but it said that these were parallel. So if these are parallel, that means that that one's equal to that one. Okay, so from that we can tell that 2 and 5 are going to be 2. It's going to be 2 to 5, and then it's going to be 3 to 3 plus x, and then it's going to be 4 to y. So we can solve that by saying 2 to 5 equals 3 to 3 plus x, and then we cross multiply. 2 times 3 plus x equals 15. 3 times 2 would be 6, plus 2x equals 15, and then we're going to subtract that 6. Let's see, that'll be 9. 2x equals 9, and then we divide by 2, and we would say x equals 9 over 2. So the first part of that is x equals 9 over 2. I think. Let me make sure. Let me double check that one. I think I got something wrong here. That's saying 15 over 4. All right, let me look at it again. Make sure I wrote the problem down right. Let me re-sketch this whole thing. All right. All right, so we've got that, and we've got that, and we've got that, we've got that, and those two are parallel, and that's 7, and that's y, and that's 5, and that's x, and that's 3 and 4. Aha, see, I wrote the problem wrong. Got to be really careful about writing the problem wrong. Okay, so I can say that 4 is to 7, and then we've got 5 to 5 plus x, and then we've got 7 to y. Alright, so 4 over 7 equals 5 over 5 plus x, times 5 is 35, and then 4 times 5 equals 4 times 5 plus x, and then we just multiply and we get 20 plus 4x is 35. And then we're going to, you guys can't see this anymore. Here, let me write these up here. 4 to 7, 5 to 5 plus x, and then 7 to y. That'll give us some more room. Alright, now 4 to 7 is 5. And we're going to cross multiply and we get 35 equals, and then we cross multiply right there, 4 times 5 plus x, and then 20 plus 4x. Now we're going to subtract 20, and we're going to get 15 equals 4x, and then we're going to divide by 4, and x equals 15 over 4. Okay, that's that first one. Now we need y, and that's 4 to 7 equals 7 to y. We're going to cross multiply, so 49 equals 4y, divide by 4, and that one's going to be 49 over 4. Okay, so there's that one. Alright, and we just have one more practice problem, and I'm going to get this straight out of the book to make sure I write that down properly. Alright, so we've got that line and that line are parallel, and they're connected by these two lines. Parallel, parallel. That means that this is equal to this, and this one is equal to that one. Okay, and that's m, and that's 7, n, 6, 4, and 3. So our ratios are going to be, if this one corresponds to there, then this one corresponds to the 6. So it's going to be m over 6. Okay, it's that first one. All right, these are equal, so that means n to 3. Let's see, m is in this small one, so I'm doing the small and then the large. Okay, so the top's the small. You have to make sure you do them right. If you flip any of them, then it's going to come out wrong. So our small is 3, and our large is n. Our small was m, and our large was 6, and then we have 4 to 7. Small is 4. I'll put it here. And our large is 7. All right, so there's our ratios. And then we can solve from there. So we can say m over 6 equals 4 over 7. And then we cross multiply. 6 times 4 is 24. Equals 7m divided by 7. So m is going to be equal to 24 over 7. Okay, so there's our first one. And then we have 3 over n equals 4 over 7. And we cross multiply. 3 times 7 is 21. Equals 4n. Now we're going to divide by 4. And we're going to get n equals 21 over 4. Right, so that's what you should have got for those two. Okay, so the homework is lesson 25. If you have any questions, just message me or leave a blank, and I'll work them on the board on Wednesday. All right, thanks guys. Bye.